All right. So we were in our pre-test, and we had to, as I recall, we had the equation all done, but we had not gotten yet to the asymptotes. So I need to go back. I'm on pre-test number 1, practice test. It's called practice test number 1. It is formatted exactly like the test. Things may be in a little bit different order in terms of what's problem 1, 2, and 3, but you are going to have to do on the test exactly what we're doing on this practice test. So I did not write down the standard form of the ellipse for problem 4A. Who has it? X minus
X plus 1.
Over 16?
Minus y minus 3 squared over 9.
All right. So we have found everything already. I am not going to repeat. We've already found it all. What I'm going to do, though, is find the equations of the asymptotes because we ran out of time for that. So I want you to think about, I'm not going to find everything else, but I want you to think about, you start by plotting your center, right, which is negative 1, 3. And then you're going to count sideways 4 and up and down 3. And you built your box. We've already done this. I'm not going to do it again. You got it written down. And you drew in your asymptotes, the diagonals of the box, and you drew in your hyperbola that looked like that because x comes first. Right? Now, we've done everything except the equations of the asymptotes. So, we know that the asymptotes are both going to contain the point negative 1, 3. To build the box, we counted up 3 and over 4, right? Up 3 and over 4. Yes, Mr. Davis?
Sunday, you need microphones, choir singing. I'm sorry.
No. Little brass quartet is playing. They don't need anything. And we do need a podium microphone.
Yep. Sorry to interrupt.
That's okay. Thank you. All right. So we're counting up 3 and over 4. So one slope is 3/4 and the other slope is negative 3/4. Remember, the slopes are always opposites of each other. Now, you need to write the equations, and you can do that however you want. I happen to like point slope, so I will always do it that way. But you can use slope intercept if you prefer. It doesn't make any difference. We're going to end up with the same answer. So one of my lines is negative 3/4 x plus 9/4. And the other one will be 3/4 x plus 15/4. Now you need to be able to do that. So again, you don't have to do it the way I do it, but you have to come up with that answer. Rachel?
Is there a directrix in an ellipse?
This is a hyperbola.
Oh, sorry.
There's actually a directrix in both of them. We're not finding them. I haven't told you how to find them.
One of the things says 4 is find a directrix for the on here. Oh, just kidding. Shoot, never mind. Yeah, there's not. That's my fault.
Okay, yeah. So, but the ellipse has 2 directrices, and they're located out here like this. And the hyperbola has 2 directrices, and they're located in here like this. So yes, both curves do have directrices, just like they have foci. I just haven't gone that far with it. I had to find those. Okay, all right, so that took care of 4A. So now we're going to go to 4B. Anybody have a question about the equations of the asymptotes? Got it? Cassie, you with me here?
Yes, ma'am.
Okay. All right. So now we're going to look at our next equation, which is 4B. And we got to figure out what it is. And in case you didn't know it was a circle, look what I've asked for. 1 is eccentricity, 6 is center, and 10 is radius. Well, that pretty much gives it away, right? If that's what it asked for, this must be a circle. But you can tell that anyway, can't you? X squared plus y squared. What's the eccentricity of every circle? 0. That's easy. We don't need it. There's no figuring. The eccentricity of every circle is 0. Jane, we're talking about math? Jane, talk about the eccentricity of circles here.
I will.
Okay. So every circle, the eccentricity is 0, and every parabola, the eccentricity is 1. Okay? The other two we got to figure out, but these guys, they're easy. All right, so we're going to complete the square, right? So here we go, x squared plus 4x. There's no factoring to do here, like there is with the ellipse and the hyperbola and the parabola sometimes. We're just completing the square. They're already grouped together. This is a really easy problem. So what goes in this blank? 4, and that goes over here also. What goes in this blank? And that goes over here also. So we have x plus 2 squared, y minus 4 squared, equal to 30. Okay. So what's my center? Negative 2, 4. And my radius is? Root 30. Remember, x squared plus y squared equals r squared. Root 30 doesn't reduce, so we just stop here. Alright, that was pretty easy. So now we're ready for 4C. Okay, so what is 4C? Alright, even without looking at what I'd asked for, which is eccentricity, 2, 3, 4, vertices or vertex, endpoints of the latus rectum, directrix, and focus, even without looking at that, you ought to be able to look at your equation and tell me it's a parabola. Yep, it's a parabola. But certainly, this is the stuff we find for a parabola. Well, it's a parabola. What's its eccentricity? 1. Everybody gets that right. You don't have to do anything and you get that point. That is a total gimme. Well, we need to complete the square. But remember, there's only one square, so we only do it once. So we'll put our x's over here, everything else on the other side. Right? That's how we do it. We put our x's, well, whatever we need to square. In this case, it's the x's. Go on one side and everything else on the other side, right? So here we go. What goes in the blank? On both sides. So x minus 4 squared equals negative 2y minus 2. So x minus 4 squared equals negative 2y plus 1. Watch it when you factor. Is that okay? Right. What do we know? What can we tell from that? We can tell our vertex is where? 4, negative 1. So remember, no points for the picture. You got to fill in the blank. So 4, negative 1 is my vertex. Which way does this open? Be careful. Which way does it open? Well, I heard down and left, and those are good choices because this is a negative, but it's one of them. I mean,
Left. No, down.
I love the people that are saying down, down, down. This thing opens down. It's an x squared. It opens down. X squared is your BFF. That's your up and down. So your axis of symmetry, it doesn't ask me for this, but the axis of symmetry is x equals 4, which means my focus is going to be 4, comma. Now to find out what that is, I need to know how far down I go. I need to know what that distance is. No, that's P. This is P. But in every equation, 4P is that number. Now you can take or leave the negative. The negative tells me I'm going down. So if 4P is 2, then P is a half, which means I'm going to come down a half from my vertex. So if I do that, where will I be? Negative 1.5. And you're free to use a mixed number. You can make that negative 3 halves. You can make it negative 1.5. Whatever you're most comfortable with. That's your focus. Now, if we came down a half for our focus, then we're going to go up a half for our directrix. And if I go up a half, it's a line, remember, it's a line. If I go up a half from here, if I go up a half, I'm going to be where y equals negative 1/2. Now, the latus rectum looks like this. Do you agree with me? I know that dot to dot, purple dot to purple dot, I know that distance is 2. So if I want to know what these 2 purple points are, I'm going to start right here at the focus in the middle, and I'm going to go back 1 and forward 1, right? Because it's 2. So where will I be? If I back up 1, I will be at 3 negative 1.5. And if I go forward 1, I will be at 5 negative 1.5. So 3 negative 1.5, 5 negative 1.5. And that's it for that guy. All right, anybody have a question about that one? Alright, so now we're ready for 4D, the last one in this section. What shape do we have in 4D? Look at your equation. What is that? That's an ellipse. I'm going to factor as I go if I can do this. 16 goes into 128. Is that 8 times, I think? I'm factoring as I go, so I don't have to recopy everything. Maybe 249. All right, here we go. Let's see what happens. What goes here? 16, but what comes over here? Which is 256. What goes here? Look, I didn't factor anything out, so I'm going to put a 9 here, and that's exactly what I'm going to put over here. So I have 16x plus 4 squared plus just plain y minus 3 squared equal to
55. 16. I like that.
I think that's going to be 16, isn't it? Negative 240 or 256. which is nice. So I have x plus 4 squared over 1 plus y minus 3 squared over 16 equals 1. I'm finding the eccentricity, the vertices of 5, 6. Focus, center, and 8, 9. Major and minor. Alright, so here we are. Here we are. Alright, where's my center? -4, 3. What's this 1 tell me to do? Don't be confused because it's a 1. Do exactly what you always do. What's that tell me to do? Go back and forth. Left and right 1. That's right. Left and right 1. So we're just coming over 1. And this way 1. So 2 of my vertices, this one's going to have 4 ordered pairs. So 2 of them are -5, 3 and -3, 3. Because I just went back and forth 1. Now this tells me though to go up and down 4. So I'm going to go up and down 4 from this point. So 1, 2, 3, 4. So I'm at -4, -1. And 1, 2, 3, 4. I'm at -4, 7. So those are the other 2. Now what? Well, let's find our foci. In order to find your foci, you need to know how far it is from the center to the focus, because you know they're like here somewhere. You just don't know exactly where they are because you don't know what that distance is. You don't know how far to go up. So we need to look at our equation. Look at the denominators. From the center to the focus is root 15. How do we find the distance from center and focus in an ellipse? Subtract the denominators and take the square root, right? So I'm going to go up and down root 15 from my center. So this is going to be the point -4, 3 plus root 15 and -4, 3 minus root 15. Now when you write those in the blank, feel free to put them together. -4, 3 plus or minus root 15 if you want to. You can write them separately, certainly, if that's easier for you. How long is my major axis? 8. You went up and down 4. How long is my minor axis? 2. You went sideways 1. Now I need my eccentricity, and then I'm all done with this problem. I'm all done with this section of the test. What is my eccentricity? Well, it's C to F, so it's center to focus over center to vertex. Now you just figured out that center to focus was root 15, right? How far is it? So you went up root 15. Now go all the way up to the vertex. How far did you go to get up to the vertex? 4. So your eccentricity is root 15 over 4. Okay. Hang in, Jack. One more section to go. All right. The last section. Here we go. Number 5 is, yeah, that'll be the end of the test. I mean, that's it. Now,
I don't think that's right.
what? We're going to do number 5 now.
Yeah.
Okay. So here we go. Number 5. This is our 3-dimensional stuff. All right. So we started out with 2 points We started out with 2 points, and we're going to find the coordinates of the vector from A to B. All right, that's easy. You're at A, you're going to B. How do you move? Tell me how you move going from A to B. -2, 3, 4. Done. That's it. 2 seconds. You're done with that problem. Now, the next one says, find the magnitude of that vector. Now remember, the magnitude is just a version of the Pythagorean theorem, but in 3 dimensions. So we're going to square, 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 add them up and take the square root. So your magnitude is going to be the square root of 4 plus 9 plus 16, which is going to be the square root of 29. Doesn't reduce or simplify in any way. That's it. The square root of 29. That is the magnitude of that vector. How do we find magnitude? Pythagorean theorem. Square, 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 add them up and take the square root. Midpoint of AB. So we're taking those same 2 points right there, and we're finding the midpoint. Now, I'm as sick of saying it as you are of hearing it. Midpoint is average. It's the middle value, the average value. So we're going to add and divide by 2. So what is our average x? 0. Our average y? 7/2, 3.5, 3.5, however you want to write it. And what is our average z? 5. Done. If you miss these questions, you're just not paying attention at all. These are easy. All right, D, now we've got a couple of vectors. So we've got -1, 2, -3. That's vector V. And I'm going to dot it with vector U. So problem D, 5D, says find the dot product of these 2 vectors. Oh, no. Yep. When we do a dot product, we don't do any, well, we can, but not in this case because we don't know the angle. If we want a dot product, we just multiply x times x, y times y, z times z, add them up. Okay? If we're doing magnitude, magnitude, cosine, we're looking for the angle between the vectors, which is not what this is about. This is just straight up, what's the dot product? So the dot product is -4 plus, whoa, plus 4 plus 0? Did you get a dot product of 0? All right, let's stop a minute. Okay, so that's the answer. Well, let's think back. What does that mean if the dot product is 0? It means these 2 vectors are orthogonal to each other. Now, you would never know that by looking at them, would you? But they are orthogonal to each other. So, what you have, here's vector V and here's vector U. They're perpendicular to each other. Or they're situated, however you want to, however they are out there in the space, they're perpendicular to each other.
Do you have to know that? No.
It's a good thing to know. I don't think it's going to be a test question, but it's a good thing to know.
Okay.
We should know more than what's on the test, right?
Ooh.
Especially since we've talked about it. It should be something that you're thinking about. You know, as you're planning your weekend activities, you're thinking about,
Orthogonal.
yeah. All right, E. What are the parametric equations of line AB? Oops. Oh, well. What are the parametric equations of line AB? So here are your 2 points. And we're going to write the equation. Here they are, your 2 points. You're going to write the equation of the line joining those 2 points. You can't do it the way we did our asymptotes earlier. because now we've got z's. So slope is kind of not there anymore. Who remembers, you know, Park, I used to have a sign back there, maybe I've already told you this. I used to have a sign back there right by the clock that said, "Time will pass, will you?" Yeah. All right, so think about that. They made me take it down because it was hurting your self-esteem. So now I just say it out loud on video. All right, here we go. Here we go. Anybody remember how to write the equation of a line in 3 dimensions? What? Well, we can't really go, we write the vector form of the line. So you remember what that looks like. The vector form of the line looks like this. Now, in a minute, we're going to go to the parametric form, which looks like this, right? I think we talked about this. I know we talked about this. What goes in this first parentheses? It's structured parentheses plus t times parentheses. That's the way it's structured, always. What goes in this first set of parentheses? A point. One of the points. It can be A or B. I'll go ahead and use 1, 2, 3. But one of the points goes in that first spot. That's going to show up right here, kids. That's going to show up right here. That's going to be the beginning of your parametric equations. You'll see it in a minute. Now, what goes here? Not the other point. Not the other point. The slope, which slope is kind of a tricky word to use here, but the movement, how the line moves from point A to point B, which I erased unfortunately, going from A to B was -2, 3, and 4. That's how this line moves. How does it go from this point to this point, which are both on the line? It goes -2, 3, 4. So now I can finish. X is 1 minus 2t. Y is 2 plus 3t. See what I'm doing? And Z is 3 plus 4t. There are your parametric equations. So right here in this spot was the point, and then right here on the t's was your direction vector. So if you can remember that, you can go straight to this. I always do that first, but you can go straight to this. These will be the point, and these will be your direction vector. Okay, one more. Find point C, so that AC equals V. All right, so here is AC, and here is V, and I want them to be equal to each other. Now, being equal to each other means they move exactly the same way, right? So if this vector goes -2, 3, 4, then this vector is going to have to go -2, 3, 4. Well, how does vector V go? -1, 2, -3. They tell me that. Vector V goes back 1, up 2, back the other way, -3 in the Z direction. Okay? Now, I need this vector to do the exact same thing. But I know I am starting at point A. My starting point is the point 1, 2, 3. So I know I am starting at this point. I want to know, where do I have to end up so that this vector moves just like this one does? What's your thought on that? I heard somebody say 0, What'd you say in the middle? 4, 0. Now look, kids, look. If you go from 1 to 0, this is your starting point, this is your ending point. If you go from 1 to 0, is this the way you move? If you go from 2 to 4, is that the way you move? And if you go from 3 to 0, is that the way you move? That's the correct point. That's the correct point. Your job was to find the end point of a vector that started here and moved like this. If you start at 1 and move -1, you end up at 0. If you start at 2 and move 2, you end up at 4. And if you start at 3 and go -3, you end up at 0. So that is indeed those are the right coordinates of point C. Got it? All right, practice test 1 done. Now, I want you to find, you're going to do test 2 on your own. I want you to find, we're going to do a few more review problems, but I want to do the ones you want. So I'll find the sheet that is called Precal A Chapter 8 Review. Precal A Chapter 8 Review. In your packet, turn the pages so you find the one that says Precal A Chapter 8 Review. The one problem on here I want to do because it wasn't on your practice test, and I am very confident it's going to be on your test. So we're going to look at the review sheet and we're going to do it together. The one I want to do is problem 4A. Problem 4A. That is going to be on your test, but it is not on the practice test. That is a screw up on my part. So we're going to do 4A. Make a note, this will be a test question. I mean, not the exact numbers, but that kind of problem is going to be a test question. So xy equals 36, and we need to find 2, which is vertices. We need to find 5, which is focus, and 6, which is center, and 7, which is asymptotes. All right? So that's the information we want to find for this equation. All right, who remembers anything? We talked about this. Who remembers anything about this equation? Dylan?
You would divide dx, or it would be 36 over x.
You can, you don't need to, you can. I did that the first time to remind you that this is actually one of your BFFs. You don't have to do that, but you can, it won't hurt anything. What is this? It's a hyperbola. And its axes have been rotated. So now that its asymptotes are what? What are the equations of the asymptotes? X equals 0 and y equals 0. That is going to be true no matter what number this is, okay? XY equals whatever. Those are going to be your asymptotes. Where's your center going to be?
0,
0, 0. Your asymptotes cross at the center. If these are going to be your asymptotes, that's going to be your center. Now, that's a positive number. You may remember what's the significance of that. It's a positive number. It's in quadrants 1 and 3. So you have this hyperbola that is in quadrants 1 and 3. Where are its vertices? Jack, put your head up. Where are its vertices?
6, 6,
6, 6, and -6, -6. So those are the vertices. For those of you that are really checked out, it's the square root of that number. Now what about the foci? This is something you just have to remember. I told you how to do it. You remember? They're going to be back here like this.
it's a square.
It's a 45-degree rotation.
Add root 2.
We multiply by root 2. So it's 6 root 2, comma 6 root 2, and negative 6 root 2, comma negative 6 root 2. Now, probably the question on the test is not going to be a 36. It could be a 25. Will this change? Will this change? These will change, but they'll be structured the same way. So if it's a 25, it's going to be 5, 5. 5 root 2, 5 root 2, right? So they're all done exactly the same way, Jack? No, but in class I did an example that wasn't a perfect square. If this number is a 6, let's say, then these points would be root 6, negative root 6, negative root 6. And then these would be root 6 times root 2, which would be root 12. So it's done exactly the same way, they're just radicals, not whole numbers. All right, so I want to make sure I did that one. Looking at the paper, is there anything else? Look down through the problems. These are all problems we've done in the last couple days. But is there anything on there we need to talk about since I won't see you on Monday? Anything on there?
What's our test?
We'll be Tuesday. I'll be the next class after that, which is that Wednesday.
Okay.
We have one more day of review. Homework's due Monday, though, regardless. Everybody's homework's due Monday. Okay, we got time to do one more problem. If you don't pick it, I will. What do we need to do? Do we need to know, do we need to write some equations? Do we need to find information, put in standard form? What do we need to do? Let's do 4C, since you don't have any thoughts, and I don't want to waste any more time. Let's do 4C. Some of you missed this on your quiz. I turned those quizzes back, didn't I? Yeah. Yeah. So, some of you missed this on your quiz because you didn't get the vertex in the right spot and you didn't have it open in the right direction. So let's go ahead and do this. Y squared minus 6y equals negative 8x minus 17. Okay, this is problem 4C on the review sheet. Alright, so 9 will complete the square. So we have y minus 3 squared equal to negative 8x minus 8. So y minus 3 squared equals, be careful, negative 8x plus 1. Is that okay with everybody? Now, I need, for this problem, I need I need eccentricity and vertices. What's the eccentricity? 1. Vertices, what else do I need? Where am I at? 3, 4, 5. I need my latus rectum, my directrix, and my focus. Alright, so here we go. Tell me about it. It's a parabola. Where's its vertex? Negative 1, 3. There is one place where it's not meant to be tricky, but if you're not paying attention, you might get those in the wrong order. It's negative 1, comma 3. So make sure you're paying attention. All right, which way does it open? Left. Very good. It opens left because it's a y squared negative. Now that means its axis of symmetry is y equals 3. Here's my focus. here's my directrix. I gotta figure out where they are. Well, that's easy if I know what that distance is. That distance is P. So in this equation, 4P is 8, so P is 2. So I'm going to back up 2. If I back up 2, I'm at negative 3, 3. That's my focus. If I go forward 2, because if I back up 2, I have to go forward 2. If I go forward 2, I'm at x equals 1. Now the last thing I'm going to say to you for 3 days here, enjoy it. You're going to have to do without me for a few days here. We're going to go up and down. Remember, the whole thing is 8. So I'm going to start here in the center, and I'm going to go up 4, which puts me at negative 3, 7, and negative 3, negative 1. So negative 3, 7, negative 3, negative 1. Is that okay with everyone? Thank you.